We're treating this as if we just started over. Hi, hello, welcome to the channel. I used to say, today's beverage is this, and actually I have a beverage. So Iran. Who knows what is an Iran? It sounds fancy, but oh my god, 70%. Oh my god. 70%. Like, you are getting 30% of frames. Yes. Very low frame. Yep. It's hopefully getting better. Yeah, thank you. Audio should be fine, right? But actually do answer my question. Does anyone know what is an ayran? It's a beverage. It's a thing you drink. Why is the voice so low? Bismillah. Do let me know if the audio is fair. Hey, this is not fair though. I just went away. And now we are, what is it called? There's a name for it. Faceless YouTuber? VTuber? I mean, I was already faceless. Anyway, I'm playing this.
Another option is to trigger retrieval with uncertainty estimates. So Flare, this is a paper by my student Zhengbao Zhang, where we tried to generate content.
No, just zero face. I don't know. I would like to. What was that thing you wrote? I have no idea. Okay. And ayran is. There we go. It's yogurt and water. Ayran. There we go. Ta-da! It says savory. I don't like savory yogurt. I like sweet yogurt. So yeah. You get yogurt, you add water. Ta-da! And it says salty. I despise salt in my ayran. I actually added some sweetness, not sugar. I'm not that evil to myself, but I added fruit preserve. Is that the word for it? As a sweetener. Which, hey, I'm still evil, but not as evil. Hello. Hi. Art thou a new chat person? I have no idea. Oh my god, hi! Thanks for the raid. That's sweet. We are struggling with technology right now. You had your channel art icon of yourself in the corner. Aha. Okay. Hello, potato. YouTube, I mean, yeah, even the stream manager is not loading for me. This is so much fun. I'm not complaining. I'm saying I'm having fun. You know what? I'll actually close the managers and just be happy with. The thing is, the manager gives me information that OBS won't. So, like, I wouldn't have known that person came by. Hi. Is your avatar photo of a potato? Can't be sure. Okay.
Content, and then do retrieval if the language model certainty is low. So here's a schematic of how this works. But basically, if we have some retrieved documents, we can say generate a summary
Oh, I just remembered we're talking about RAG. Why is the voice so low? That's weird. I'm using a different headphone. Mm. Um, and we are retrieving documents to help our LLM understand stuff better.
About Joe Biden.
Huh?
And when it generates a summary, maybe for the first output, the language model has
Join us in the learning and struggle in the bad tech of my side. This is how you learn about technology. You experience it. The no salt, non-savory iron. It's flavored like with mint or rose water. Good question. Good question. The yogurt is the flavor. Like, what else do you want? I prefer just water and yogurt. Done. The salt part makes it annoying, and mint, actually, I don't mind it. Like there is the type you buy in our stores. Let me Google it. If I write Iran, and then if I write, and then the DOU, there we go. Well, it's gone, but you can see it in the search bar. There are alternative names. One of them is, I don't know how you would read that, but I read it as I think the Persian version is dogh with a gh at the end. Yeah, yogurt milk. Ooh. See, this is another way of dove. Really, where did this v come from? Yeah, lukewarm. I prefer lukewarm. Thank you. Yes, I actually don't drink it cold. Oh, that's funny. But yeah, it's healthy enough because it's good. And what was I trying to say? If you get store-bought ones and you don't make it yourself, for example, something like this one, like these fancy ones, it's mostly minted, but you don't have to add mint to it yourself. And what else is out there? Yeah, I don't like it. Savory yogurt. I like sweet yogurt, which is, I think Americans call them Greek yogurt, I think.
has high confidence. And because the language model has high confidence, we just generate the output. However, in the next step,
Yeah, you don't need to if the yogurt is already sweet. But if it's not, I just try to stay away from sugar. There are other ways to sweeten it. Honey is another way. But it's literally to your preference, because you can make it savory and salt, or you can make it sweet. You can have it be lukewarm, you can have it be cold, because in the summer we just add ice cubes to it. I think it's my dad's favorite drink. So the fact that I'm drinking it makes me feel like I'm going into my age, getting old. No, each time I say I don't drink it, it's because it's savory and salty. That's literally the only reason. If it's salt, I'm not going to drink it. I still remember drinking from a village somewhere. I know where, but I'm just saying. It was like the best thing I had in my life. I will never have that experience. It was so sweet.
it might generate something like saying Joe Biden attended the University of Pennsylvania, where he earned a law degree.
Thank you, Potato Wizard. Sorry for the the subject going not to technology. Drinkable yogurt. I think maybe Japanese people have flavored drinkable yogurt, which is most of the time banana or strawberry. So yeah. I think, what is that? It's better known where I am from as an India drink made with yogurt. But what is that? LASSI? I don't know. Beverage. Drinkable yogurt. Yakult. Yeah. That one I know of. Smoothie like yogurt-based drink in India. But what does it taste like? Is it salty and sugar and salt? Hey, dude, how can you add those two together? Looks yummy. Why is it colored? Oh, I actually don't really add yogurt to smoothies. I add milk. Thanks. Is internet fine? Twitch just crashed on me and is back. Okay, let me try opening the manager one more time. Bismillah ar-Rahman ar-Rahim. Does it scare people when I speak Arabic-like stuff? Don't be. I think internet is better now, and I can see actual chat. Okay, cool. Huh? Oh, cool.
Like,
Is this summarization in a way, or is it just generation? Because like we have his age, we have where he attended university and got, this is all coming from Wikipedia, right? No. Yes.
saying Joe Biden attended the
I think we're better. I think I don't know why, like half an hour in it gets better. I really don't understand this.
University of Pennsylvania, where he earned a law degree.
Oh, okay.
But the model might not be very certain about this. It might have a low probability of certain important entities. And so based on this, we then form a query where what we do is essentially we blank out the low probability parts of this, and we do a search. And so this is also a little bit like the hypothetical document embeddings method where we
Wait, is this not real? Oh. Huh. Why are these dates so not, like, very different? Okay. It's both a joke and not, because, oh, okay. Thank you. I think people are still scared of, not Arabic, but words that are related to Islam. And I don't, it's not, it's like I don't care about using it, but also like trying to just make it normal. Yeah, because like this doesn't matter, but what is that dude's name? Oh God, Sacha Baron Cohen's movie. What is it called? Help me. Like it uses yeah. Why can't I find it? Baron Cohen. Yes, that's his name. Borat. There we go. Borat. No, actually, it's the dictator. It's definitely the dictator. You know, just that part. I think there's a level of like people being scared of yeah, it's not, I have not faced it, I think. I'm just saying there is this like thing at the back of the person's mind. It's like, oh my God, that's Arabic, you know? Or I don't know. I'm saying be scared of me, okay? There.
we basically create a document that we think will look similar to the document that we want to find. We use that to create search results, and then we generate the output. And then we continue doing that, and whenever we have a high confidence output, like the one here, we don't do any retrieval, we just, generate.
Oh my God, I got it. I actually understand what's happening here. We have the our version and the RAG version, and we compare them. So then we know how certain we are. That's really cool. But isn't it like twice the work? Cool. I'm glad that you don't know.
Directly from the parameters of the model. But whenever we have low confidence outputs, we do the retrieval and base the output on this.
That's
And
cool.
so I think this is, a nice method that could potentially be used. The downside to that is you might sometimes need to generate twice because you would generate.
Oh, wow. That's cool. I also have Arab friends because I'm not an Arab person. I mean, Arab is not really a nationality, but you know what I mean. Person who speaks Arabic. Um, that's cool. My fantasy is from the serials I watched. Series. It's called Serial in Fantasy. Um, and you know, most of the time it's easier to understand than it is to speak. So yeah, let me know what fantasy you know so that I try to answer you. Um, it's okay if you write it in English. You don't have like you can write it in Latin.
The output once and then find the low confidence parts and generate again. But you know, if you really care about the kind of quality of the output, this is, I think, a reasonable thing to do.
Mm-hmm.
Okay, so now moving on to the token by token retrieval methods. The kind of original or one of the methods that popularized this idea of token by token retrieval.
You know, I keep saying, why is the voice so low? Because my
Is something.
oh wow, that's loud. My headphone has what is it called? The thing that a knob, and it's like all the way down. Wow. Technical difficulties.
Called KNN-LM. And the way it works is it retrieves similar examples and then uses the following tokens from these examples. And this is kind of like a very powerful count-based bigram model in a way. So if you remember back to when we were talking about count-based bigram models, what we would do is we would take the.
Yeah, you already forgot everything. That's cool. Except for salam. Okay, so they say salam. Their tone of speaking is different. Like it sounds so poetic the way they speak. It's beautiful. Yeah. Okay. Does my salam sound Persian? Salam. And it's like, to say how are you? I think you're like, hale shuma chatori, right? Shuma means like you, the plural you, because they don't speak in singular you, even though they have it. But if you do, it's disrespectful. Yeah, Persian is a beautiful language. I'm not worthy of it.
Previous token, and we would calculate the probability of the next token by summing up together all of the next tokens and dividing by the total number of times that previous token occurred. And so, given that background, we can talk about how the KNN-LM works. So we have the text context, X, and we want to generate a target output.
Mm-hmm.
Separately from this, we have all of the training contexts. So this is all of the contexts that appeared in our training data. And we encode all of these training contexts.
Do we know these locations by... How do we know these locations?
Specifically by calculating the representation of the final layer or near the final layer of the model. And so we encode that as representations. Separately from that, we remember the next word that appeared after this context. So now we have a data store consisting of representations in next words. We then take the representation of the current context and we calculate the distance between the current context and all of the other similar contexts in the database. We take the nearest K. So we take the top K examples here, which would be Hawaii, Illinois, and Hawaii. We then do some sort of normalization based on the distance. And this gives us a probability distribution over all of the next tokens. Sometimes these tokens are duplicated multiple times. And so we aggregate all of these counts to be Hawaii, for example, 0.8 and Illinois 0.2. And then we interpolate this with the probability given by the standard language model using an interpolation coefficient lambda. And this gives us our final probability.
Aren't they doing too much? Too many things are happening. How useful is this?
So the nice thing about this is this allows us to explicitly ground our outputs in individual examples. And it's a pretty effective way to improve the probability of models, improve translation, and other stuff like this. The disadvantage of doing this is that it kind of adds an extra component of the model. It adds extra
Calculations.
kind of hyperparameters like lambda and things like this. So it is a little bit finicky and it doesn't work in all situations. And so another method that we proposed
Did you understand the Farsi or did you understand this part that our professor is explaining to us? Because both are difficult. This one a bit more.
by Amanda Birch, who gave the previous lecture on generation in this class, is Unlimiformer. And basically what Unlimiformer does is it notes that attention itself is an inner product search.
Unlimiformer. That's funny. Okay. We're using attention?
And it does top K attention. And the way we do this is we first process the input with a sliding window and then perform attention using a vector index. So if we have a really long input that we want to encode.
This sounds fancy. Oh, the ML part. Okay. This sounds fancy. It's 2023. It's using attention. Didn't sound fancy because it was 2019.
Perform attention using a vector index. So if we have a really long input that we want to encode, what we do is we first encode chunks. So we encode, for example, AB, then we encode CD, and we encode EF.
Sliding window, got it.
We concatenate them together into a big index of one long input. So in a way that this is similar to what they did in the KNN-LM, concatenate all of these embeddings into a single input. But the difference is that this is done with the values that we are attending to, as opposed to just the final layer. And the interesting thing about this is now we have an index of one long input. And when we want to do our next version of attention, we do KNN search from the query. We take the retrieved hidden states, and then we just do attention over them. So the nice thing about this is in the extreme case, this makes no changes to the model. What I mean by this is, let's say our input was small enough that we could encode it in only a single chunk. And for KNN search, we also did KNN search. We did, exact KNN search over all of the embeddings in the chunk. In that case, this would just be normal attention. It's exactly the same as normal attention. However, there are some approximations that go into here, like when we encode chunks, they might not be exactly the same as if we encoded the entire thing together, and we're also chopping off.
The chunks and the sliding window thing is not word piece, right? It's not like subword. That's the thing, not word piece. Word piece is an algorithm.
Some of the values with very low kind of inner products. And so because of this, there are some approximations being made, but in the extreme case, if we made no approximations, this would just be exactly the same model as we were using before. So I find this pretty attractive, and empirically it gives very good results over long distances. And
I said it's fancy. He's saying it's fancy.
and we can always make our approximations better and improve this model as well. So I think this is an attractive method that you might be interested in taking a look at. Okay, for the final part of this, I'd like to talk about long context transformers. And these are models that are explicitly trained in a way that allows you to attend to longer contexts in an efficient manner. So one way that we can train over longer contexts is just append all of the context together. And in fact, shortly after transformers came out, this paper by Vojta et al. Demonstrated that doing this can learn, interesting document level phenomena. So it can identify when multiple words refer to the same thing or co-reference and other things like this. However, the problem with transformers is that
What's with this one here? It heart. Like heart it? Like that? End of sentence, beginning of a sentence. There was a is there was a time I would have lost my heart to a face like yours. And you no doubt would have broken it. No doubt. Okay.
Computation is quadratic in the sentence length because you're multiplying all of the query vectors by all of the key vectors. And that basically causes a big problem if your sequences become very long. So if we go back to what we did in RNNs from the very beginning of the class.
Oh, really? Okay, it's about reference? That's cool. Ah, okay. Attention. Ah, okay. No wonder. It says reference.
This has become very long. So if we go back to what we did in RNNs from the very beginning of the class, in RNNs, they don't have this problem because computation is linear in the length of the sequence. You just pass along the RNN state, and every single time you do the same computation over it. So there's no quadratic term in calculating RNNs. Another thing is that when doing RNNs, you can actually pass state infinitely during the forward pass by just calculating the hidden state and then throwing away the rest of the computation graph that was used in calculating that hidden state. And there's no approximation that goes on there. So unlike in Unlimiformer that I was talking about before, where we needed to make approximation.
I love the name of the Unlimiformer. Is that so much like that? Is it Megamind? That makes something that you can't pronounce? I think it's Megamind. Anyway, the truncated back prop, meaning you move and you just cut off your tail?
None need to be made in this case. However, there is a problem with doing backprop because in order to do backprop, normally you maintain the entire, state of the computation graph. And so a common method to fix this is basically you pass along the RNN state from the previous sentence, but you just don't do backprop into the previous sentence. And this is called truncated backprop or truncated backpropagation through time.
Oh.
And this allows you to essentially train models.
You said it before him. Wow, wow, wow. Good job, good job.
With infinite, at least models that can pass along context infinitely, even if you're not backpropping into the encoder there. So, of course, a problem with this over long contexts is recurrence. Recurrent models can be slow due to the kind of sequential dependence. They're not ideal for, running on GPUs or things like that. And this is improved by recent architectures like Mamba and RWKV, which are more conducive to GPU-based training while still maintaining linear time complexity. And so I'm looking forward to talking about that more in a future class. So actually, if we take this idea of truncated backpropagation through time, this can also be applied to transformers. And there's a really nice paper.
Oh my God, Z is here. Guys, Z is here. Why are you here? Oh my God. Doing great. How are you? I was literally just listening to your violin cover before streaming because I love Howl's Moving Castle. It's like my comfort movie. And you did a violin cover to it. And the tracking, it was so fancy. Good job, mashallah. Good job. Guys, you really need to follow Z's stuff. I'm guessing it's late at night, maybe. So if you need to sleep, please do that.
Transformer XL, also created by Zahang Dai, who was formerly at CMU. And what this does is this attempts to fix vectors.
Oh yeah. Wow. I'm a bit speechless because the tracking was really cool. But I also read your comments saying that you are picking it up after like years of not practicing. So that's also something not easy. So wow, wow, wow. Thank you. The stream started off rough. It's going smoothly thanks to your grace. Okay. Here's me waving goodbye to you. It's not a wave. Be content with just a hand. Sleep well.
From the previous sentence. So if we have a standard transformer in transformer XL, normally what we do in the standard transformer is each vector attends back to all of the other vectors in the current context. What transformer XL does instead.
Wow, wow, wow. I mean, you were already cool and now you're like Sherlock level cool. And I'm not jealous. I'm not jealous. I know I can't play any music. You know what? I can play a laptop keyboard. That's good enough. Thank you. Same here. Sleep well. Have lovely dreams.
Is when you have a new segment that you want to do backprop into, you have a new segment that you want to basically train over, you also attend to all of the previous tokens in the previous segment, but you don't do backprop into them. So this is essentially truncated backpropagation through time from the transformer perspective. This is also really nice because what it allows you to do is if you have a multi-layer transformer, it allows you to attend far back. So if you look at the last layer, it's attending to things in the previous context window. But the second to last layer is attending to things in the not just one context window before, but multiple context windows before. And actually, this allows you to very effectively attend to very long contexts because each time kind of the context expands in an exponential manner. So recently, there's a popular model called Mistral that I'm sure a lot of people have heard about, and this is using sliding.
I have heard about it.
Window attention, which is essentially the same mechanism proposed by Transformer XL. So this method is still used in very practical systems. Another paper that has been pretty influential in this general area is something called sparse transformers. And the way sparse transformers work is instead of attending to every single previous state, you attend to every n previous states. And what this allows you to do is this allows you to essentially create something like the strided convolutions or pyramidal recurrent neural networks that I talked about earlier. So what this looks like essentially is you have this, like if you have a particular state, it might attend to all of the previous n tokens, but then it also attends to all of the previous kind of M chunks. So you kind of have a combination of local and global attention. Or not local and global, but local and kind of longer range attention. And this can be very effective because you can attend to, much longer contexts with a minimal increase.
That's really cool. Like, is that level of attention? That's really cool.
In a computational complexity. So another method that's a little bit like this, or it's very similar in spirit, but slightly different in implementation, is something called the compressive transformer. And in the compressive transformer, you also have this idea of a local memory and then a longer term compressed memory. But you have an explicit compression step that directly essentially generates this compressed memory itself. And so this is a little bit more flexible, I guess. It allows you to take all the, relevant things from your local memory and compress it down. So it's another method that's worth thinking about. Finally, there are some very interesting methods that do low-rank approximations of transformers. And so calculating the attention matrix is expensive, but this is a matrix. And because it's a matrix, we can also approximate it with a lower rank matrix. And there's a couple methods that do things like this. The first one is something called linformer, which adds low rank linear projections into the model at appropriate places. And there's another one called Nystrom-former, which approximates using the Nystrom method, which is based on sampling landmark points. But basically, the general idea behind this is normally we do this kind
I don't think I've heard of Nystrom.
of softmax over, a very large attention vector. But instead, we can approximate the softmax by having some low rank vectors, kind of like what we used in LoRa, and nonetheless get a reasonable approximation of the softmax used in attention. Okay, so we're nearing the end of what I want to talk about today. And finally, the thing that I'd like to talk about is benchmarks for long context models. And there's a few benchmarks. One very well-known one is something called Long Range Arena. This is a composite benchmark containing mostly non-NLP tasks. And it's definitely used for long sequence modeling, but the results on the Long Range Arena actually tend to diverge somewhat from the results that you get for long distance language modeling. So in addition to this, another benchmark that I personally like and have used a bit is something called Scrolls, which combines together a whole bunch of kind of QA style or summarization style tasks that have very long contexts, including over narratives or books or government reports or other things like that. So you can also take a look at this if you're interested in kind of benchmarking longer range models.
Large metrics into smaller row and column metrics are multiplied to approximate a larger matrix. Maybe like a multidimensional one.
Okay. The final thing
I will say it looked really cool.
I'd like to talk about is now that we have retriever models, we have reader models, we maybe even have reader models that can effectively use very long contexts, like the ones that we retrieve over whole documents. How do we effectively use them in our models? So there was a very nice paper by Nelson Liu at Stanford about a phenomenon that was coined lost in the middle. And basically what it does is it demonstrates that many, many different models, including state-of-the-art models, pay less attention to things in the middle of long context windows. And so if we have an answer and we put it in, the first position in a concatenated context or the 20th position in a concatenated context, it tends to attend more to the ones at the beginning or the end. In contrast, the ones in the middle kind of get lost, hence the name lost in the middle. And the problem with this is, if we are doing something like retrieval and reading, then that's maybe not such a huge problem because we could just put, the highest scoring documents at the beginning that might even be more effective than, concatenating lots of low scoring documents together. But if we want to read a really long document and synthesize something without doing kind of another scoring step, that can be an issue. And also, our retriever is not perfect. So we would like the reader model to do a good job with the outputs that it has.
Okay.
So there are methods to ensure use of relevant context. So of course, better retrievers make more relevant context. You can do, re-ranking or other things like that, and only include the context that looks most relevant, or refine your reader model. But there's also methods that can decide whether context should be used in the first place. So there are methods to decide whether to include passages or not.
Mm-hmm.
And also recently we proposed a method to filter down to parts of retrieved passages to have only appropriate content. And this is a model that we called Filco. It basically filters the context down to the most relevant content that we think is appropriate, and that allows us to get better results when it's fed into the generator.
Mm.
So that's all I have for today. Thank you for watching the video, and for people in the class, I'll be happy to take questions on Piazza or during the office hours that I have planned.
Because he was not recording from the class. Next video is, I'm not gonna start it, but distillation, quantization, and pruning. Fun. Okay, so that's it. Did I open this? That's the other. Okay, got it. Can you believe it's a Thursday? Yes, I made it. I think today's going to be a very busy Thursday for me, so we'll see how that goes. Because I was hoping to go to the cinema because I want to see The Wild Robot. Don't know if I can do it today or sometime during the weekend. Wish me luck on that. And yeah. Let's see, like the workday, the during work week streams are way too short. I'm like, I really should stream during the weekend. So let's see how that goes. That's it for today. I hope you had a lovely time, and I wish you a lovely rest of the day, and have some iron. How do I say it? Anyway, Iran. I think the R is a bit softer. Iran, not Iran. No one ran anywhere. Anyway, thank you. Yes. According to the internet, it's like another win for DreamWorks. Yeah. Okay. I hope you have a lovely rest of your Thursday. Oh my god, nice. I'm saying, wait, Pepe Hands? You have you ever commented before? If not, hi, hello. What was I about to say? Oh, thank you, of course. I'm saying 12 o'clock is better than like super late, so I'm glad that you're sleeping at a reasonable time. Have lovely Ayn Rand. Please don't. Okay. I can just shrug. What can I do? I'm gonna end the stream in 5. Thank you so much for being here, and hello and goodbye, Pepe Hands. I like your name. Ending the stream. Inshallah, see you tomorrow if it all goes well. Let's see. Ending the stream in 5, 4.